On January 29, 2025, a number appeared on a NASA webpage that most people would never normally check. And within days, that single number had triggered headlines in nearly every major news outlet on the planet, 1 in 83. That was the calculated chance, as of that date, that a newly discovered asteroid called 2024 YR4 would slam directly into Earth on December 22, 2032. A roughly 1% probability, which sounds small until you understand what that number actually meant in context. It was, at the time, the highest impact probability ever recorded for an asteroid of its size in the history of modern asteroid tracking. And over the following weeks, instead of quietly fading away the way these warnings almost always do, that number did something it was never supposed to do. It kept climbing. This is the real story of the asteroid that genuinely alarmed the global scientific community. Why the James Webb Space Telescope had to be called in on emergency notice to help settle the question, and what the answer actually turned out to be. An answer with a genuine, ongoing twist that scientists are still tracking today in 2026, right now. Asteroid 2024 YR4 was first spotted on December 27, 2024, by a telescope in Chile as part of a routine survey scanning the sky for exactly this kind of object, a near-Earth asteroid whose orbit happens to cross paths with our own planet's path around the Sun. In the earliest days after its discovery, astronomers had only a handful of observations to work with, nowhere near enough data to calculate a precise, confident orbit, and initial estimates of its impact probability sat at a level low enough that it barely registered outside of specialist circles. That changed quickly. As more observatories around the world turned their instruments toward the newly discovered object, and as astronomers fed each new data point into increasingly refined orbital calculations, the estimated probability of an Earth impact in 2032 did not settle down the way it usually does with newly discovered asteroids. It rose. By the end of January 2025, NASA's own Center for Near-Earth Object Studies had the impact probability sitting at roughly 1%, 1 in 83, a genuinely startling figure for a large near-Earth object with a well-constrained future impact date. And it kept rising from there. By early February, NASA's Center for Near-Earth Object Studies had updated the figure again, this time to 2.3%. Paul Chodas, the director of that center and one of the most experienced planetary defense scientists in the world, spoke to reporters during this period with the kind of careful, measured urgency that professionals in this field use specifically because they understand how easily public panic can spiral out of proportion to the actual risk. He noted that dozens of observatories, more than 50 of them around the world, had already contributed over 350 individual observations of the asteroid, all in an effort to nail down its orbit precisely enough to either rule out the danger entirely or confirm it. The number kept climbing anyway. By mid-February 2025, the estimated probability had reached 3.1%, the single highest impact probability ever recorded for an asteroid of this particular size class since organized asteroid tracking began. For a few genuinely tense weeks in January and February of 2025, this was not a fringe conspiracy theory circulating on social media. This was the official, published, continuously updated risk assessment from NASA's own planetary defense team, rising week after week in a way that unsettled even the scientists, whose entire careers are built around calmly explaining why these things are almost never as dangerous as they initially sound. Here's why an asteroid like this genuinely warranted this level of attention in the first place. Based on the amount of sunlight it reflected, astronomers estimated 2024 YR4 measured somewhere between 130 and 300 feet across, roughly the height of a 10 to 20 story building. That size class matters enormously in planetary defense circles, because an asteroid this large is generally too small to trigger the kind of global, civilization-threatening catastrophe associated with the object that wiped out the dinosaurs, but more than large enough, if it struck a populated area, to level an entire city with a force potentially equivalent to hundreds of Hiroshima-scale nuclear detonations. This size range earned 2024 YR4, the nickname that spread rapidly through global media coverage, the city killer asteroid, a description that, while dramatic, was not actually an exaggeration of the genuine physical consequences a direct impact from an object this size could cause. With the probability of impact continuing to climb rather than settle, and with the asteroid due to swing out of range of ground-based telescopes within just a few months, astronomers made a decision that itself signals exactly how seriously the situation was being treated. They requested, and were granted, emergency observation time on the James Webb Space Telescope, a resource so heavily oversubscribed under normal circumstances that astronomers typically wait months or years for approved observing time. Emergency allocations like this are reserved specifically for genuinely time-sensitive situations, and in this case, the urgency was straightforward. Webb represented the single best instrument available anywhere on or near Earth capable of gathering the kind of precise data needed to nail down both the asteroid's exact size and its exact trajectory before it disappeared from view entirely. Webb's first observations of 2024 YR4 came in March of 2025, using both its near-infrared camera and its mid-infrared instrument, and the results delivered a mix of reassurance and fresh complexity in roughly equal measure. On the question of size, Webb's data suggested the asteroid was actually somewhat larger than earlier ground-based estimates had indicated, measuring between 174 and 220 feet across, a range NASA described as comparable to a 10-story building, and noticeably rockier or more reflective than initial models had assumed. On the question everyone actually cared about, whether this thing was going to hit Earth, the news, thankfully, went the opposite direction. As the additional Webb data combined with the accumulating ground-based observations, astronomers were finally able to narrow the asteroid's calculated future position enough to definitively rule out an Earth impact. By late February and into March of 2025, NASA's Center for Near-Earth Object Studies confirmed the Earth impact probability had collapsed to essentially zero. The city-killer asteroid, for all the genuine alarm its rising numbers had generated over the preceding weeks, was not going to hit our planet after all. That should have been the end of the story, and for most people who had briefly followed the headlines in January and February, it effectively was. But scientists studying the refined trajectory noticed something the earlier, less precise calculations had not been able to reveal clearly. While the chance of an Earth impact had fallen to zero, the same improved data suggested a small but genuinely non-trivial chance that 2024 YR4 could instead strike the moon on that same date, December 22nd, 2032. As of April 2025, NASA placed that lunar impact probability at 3.8%. Then, in May of 2025, astronomers led by Andy Rivkin at the Johns Hopkins Applied Physics Laboratory used Webb's near-infrared camera to capture one final observation of the asteroid before it finally became too distant and too faint for any telescope, in space or on the ground, to track any further. That last critical data point improved scientists' knowledge of the asteroid's exact expected position on the day in question by nearly 20%. And when that improved precision was run back through the impact calculations, the estimated lunar impact probability did not fall. It rose again, but from 3.8% to 4.3%, the figure that currently stands as the best available estimate for whether this asteroid strikes the moon in December of 2032. It is worth pausing here to be genuinely clear about what a lunar impact would and would not mean, because this is exactly the point where careful, honest science reporting has to resist the temptation to manufacture drama that the actual facts do not support. NASA has been explicit and direct on this point. Even in the event that 2024 YR4 does strike the moon in 2032, that impact would not meaningfully alter the moon's orbit, would pose no danger whatsoever to Earth, and would have no measurable effect on tides, eclipses, or anything else that touches life here on our own planet. What it would represent instead is something scientists studying the moon have actually described with a note of genuine excitement rather than concern, a rare once-in-a-generation opportunity to watch a precisely tracked, well-understood asteroid strike a real-world target in real time, potentially even producing a flash of light visible from Earth with the naked eye, and offering planetary scientists an unprecedented natural experiment in exactly how impacts of this scale actually behave, data that is normally only available by studying ancient craters formed millions or billions of years in the past. As of right now, in the middle of 2026, asteroid 2024 YR4 has moved entirely out of range of every telescope currently capable of observing it, whether based on Earth or in space, and it will remain effectively invisible to us until it swings back into a favorable observing position sometime around 2028. When that happens, astronomers plan to immediately resume tracking it, refining the current 4.3% lunar impact estimate one way or another with fresh, updated data. Until then, the number simply sits there, unresolved. The best available estimate based on everything currently known, a live example of exactly how planetary defense science actually works in practice. I'm methodical, transparent about its own uncertainty, and willing to publicly report a number even when that number is genuinely unsettling, rather than quietly waiting until the story becomes more comfortable to share. What makes this entire episode worth understanding properly, rather than simply remembering as a brief moment of internet panic that turned out fine, is what it actually demonstrated about how seriously the global scientific community takes threats like this, and how quickly and effectively that system actually worked when it mattered. In the span of roughly 2 months, more than 50 observatories around the world coordinated over 350 individual observations of a single, small, previously unknown asteroid. When ground-based telescopes reached the limit of what they could measure precisely enough, astronomers successfully petitioned for and received emergency time on the most advanced space telescope humanity has ever built, redirecting a heavily oversubscribed scientific instrument specifically because a potential planetary threat took priority. And within a matter of weeks, that combined global effort took an asteroid initially estimated to have a 1 in 83 chance of striking Earth, and definitively ruled out that outcome entirely, while simultaneously discovering and quantifying an entirely new, smaller-scale risk to the Moon that nobody had even been asking about when this story began. That is not a story about an asteroid nearly destroying a city. That story never actually came true, and it is important to say so plainly rather than let the initial scary headline linger uncorrected in people's memory. What actually happened is, in its own way, a genuinely reassuring demonstration of exactly how modern planetary defense is supposed to function, a real potential threat identified early, tracked rigorously by an international coalition of scientists and telescopes working together, and resolved with real data rather than guesswork, all while being honest with the public at every single step, even when the numbers being reported were still rising and still genuinely uncertain. The story is not entirely finished, though, and that is worth being honest about, too. Somewhere out there right now, moving along its multi-year orbit, invisible to every telescope currently capable of finding it, asteroid 2024 YR4 is quietly making its way back toward the inner solar system, carrying with it a 4.3% chance of striking our own moon in December of 2032. When it finally swings back into view in 2028, astronomers will be watching, ready to refine that number one more time, using tools considerably more advanced than anything available when this asteroid was first discovered just 2 years ago. If you want to know what happens when 2024 YR4 finally comes back into view in 2028, and whether that number keeps climbing or finally gets ruled out entirely, subscribe and turn on notifications, because this is one asteroid story that is genuinely not over yet.